All right, Chris and I are going to talk about equity, scenic, and a new scenic initiative. But let me start off by saying thank you to all of you. Everything that I'm going to talk about, everything that my counterpart yesterday from San Diego State University, Mike Farley, talked about is the result of your work. None of it would have been possible without you. And I want to call out in particular some of the vision that allowed us to get to where we are today. And that goes back to Larry. You know, the genesis of everything that we're talking about starts back in the supercomputing program back in the 1990s with the concept of the metacomputer, but it lacked the middleware. When he got to Cal IT2, it started with Optoputer and Phil Papadopoulos and Prism, and then it moved into the PRP. Tom, John, Dima building that into the NRP, and then Frank deciding that he would infuse his knowledge of OSG and this messy combination of heterogeneous resources trying to meet science. All of it contingent upon the network. That's a really important thing that perhaps we don't talk enough about. So I just want to thank everyone for everything that I am now able to talk about. So I'm going to talk to you about a new NSF award that was given to San Diego State University. I was the prior CIO at SDSU. I'm now the CIO at the Salk Institute across the street. And building on what we learned from the integration of our instructional cluster, which had been funded at SDSU, we made a proposal to the National Science Foundation, Kevin CC Star Program, the regional award in that area, to develop the technology infrastructure for data exploration. So TIDE is a brand new award. It was just awarded in December to San Diego State, and more importantly, to the California State University system. Our partnership is CSU San Bernardino, Cal Poly Humboldt, CSU Stanislaus, and SDSC. And I think it's important as we think about the genesis of everything that we're doing, every time that there's something new in the NRP, it's like a new sourdough bread. Someone's taking something that they had before, contributing it, it ferments for a while. I think Mike talked about some of the challenges of that fermentation stage when you're dealing with instructors, and then it grows to be something that you can actually do something with. So the partnership was for the CSU to think about the needs of the largest public university system in the United States that has never had a computational core. There's never been anything to serve the science needs of CSU across all of the campuses. And part of that has to do with the missions of the CSUs being instructionally focused, but also increasingly over the course of the last 2 decades to make students competitive moving into research environments. So the TIDE ecosystem is this new $800,000 award. It funds new compute resources, 616 cores, 73 GPUs, 14.5 terabytes worth of RAM that will be integrated into the NRP. Equally important, and you heard the conversation about the translation that has to happen as you're doing metacognition, as you're moving between devices, as you're trying to engage with users. The secret sauce, we think, of the approach to TIDE is not just the hardware, but it's really the importance of having the people who can take time with folks who are non-traditional users, instructional and research, and translate this very wicked challenge, which is containerization. Containerization is enough to put off most scientists from doing things differently, regardless of their level of subject matter expertise. Many of them simply start and go, I'll just go buy my own GPU that sticks in a data center, and that's where they stop in their science. NRP gives us a different way to look at that, but you have to be able to do this translation. So the folks are a critical component of that. And then we rely on the networks, right? The Science DMZ that is at San Diego State University, going back to Scenic's infrastructure, both its network that is for the public sector as a regional optical network, and its ability to get to other high-performance research networks. And all of this built on the foundation of the NRP. So that's sort of what TIDE is about. The role that regional optical networks play in TIDE is foundational. It's critical. It's essential. It is the thing that allows anything that we are talking about to happen. And I think one of the things that we don't think enough about is sort of, if you go back to Tip O'Neill, if all politics is local, all networks are also local. And science happens regardless of what network you have for it. So the beautiful thing about the infrastructure that we have with Scenic is that we have the ability to put a machine in a very large machine room at SDSU that we were never able to convince faculty on our campus that they should put their machines into. So if you're looking for colo space, we still have space. We put research infrastructure in that. That ties back to scenic. It gets to the HPR connections. But most importantly, the science drivers that you see from biomedical to natural sciences to AI to archaeology and geology, mathematics, all of those get back to the CSU campuses on the standard scenic connections. Science networks, useful, but not always necessary to get science done. And I think we want to talk a little bit more about what that means perhaps for future runs. I want to talk about what it allows us to do that we can integrate back into this fabric or ecosystem that is NRP. So we go into Nautilus. What that allows us to do, and probably the first bullet can't be overemphasized enough, it allows us to have someone else system administer our equipment. So we can engage with users to make the utility of that equipment materialize. This might seem like a little thing, but I will tell you, as the CIO at prior Montana State University and as the CIO at San Diego State University, hiring system administrators to do high-performance computing system administration in small universities is a fool's errand. We failed for 2 years to do this at San Diego State University. So in the old model, when you fail to buy the system administrator, it doesn't matter what you can do with the hardware because you never get the hardware because you can't maintain the hardware. NRP disintermediates all of that. It allows us to focus on user engagement and driving science faster than worrying about hardware. That's the disruption. It also gives us the ability to have burstable resources. Everybody here knows that, but I think the scale of what we're able to get into is really a power law change. I'll talk a little bit about that in terms of equity here in just a second. And then most importantly, and the reason that the thank you was really heartfelt, is there are 50 institutions that are collaborators, 300 research groups. Everything that anyone is contributing here is for free, right? Think about the NRP as an academic cloud. At no point in the NRP are you asked to enter a credit card number. That is a radical thought for most people who are used to dealing with a cloud resource, right? Everyone here is contributing for a common good. And I just think that it's really important that we think about the equity that that allows us to achieve at scale because of our ability to work with organizations like Scenic, Quilt, and the intellectual powership that's here in the room. Let me talk again, old CIO hat on, just about some thoughts about research network challenges for the CSU. Talked about the fact CSU is the largest public university network in the United States, also largest system. First thing that's important to know about the CSU is that there's really limited deployment of science networks on any of the campuses. The system itself funds all of the networks on all of the campuses. They are production networks. The system has never put a dime into a research network. It's outside of what the system believes is the mission of the CSU. It leaves that to the campuses. So there are 2 campuses, San Diego State University, because of partnership with Larry and Tom, who've been able to do the right infrastructure. San Bernardino is another building up that infrastructure. Humboldt, another building up that infrastructure. But we're talking 3 of the campuses that are doing a hardware-based science DMZ as their approach to things. There's also limited staffing. If you look at the 5 folks who are here from Humboldt today, their day job is enterprise IT, and then they get to do a little research. And that's true for almost any IT professional that's going to exist in this very large system. Research is a thing that you get to do on the margins. It's not a thing that you get to focus on. So if you have to focus your time on only administering hardware, you're never going to get to engage with the user. I think the other thing that we all know, but it really requires how we talk about things and the importance of the trade-offs that are there. Science networks are inherently bursty, so it's really difficult. And I'll put back on my CIO hat, who used to sit in a cabinet, who used to explain to the president why we should buy the instructional cluster. If I had to sell a science network as a thing and I had to use network traffic to do it, that would be a poor ROI conversation. The network is an essential component, but it's bursty, right? Most of the 100 gig networks that we have, and I can tell you looking at the data at SDSU for the last 2 years, they peak episodically at like 20 to 30 gigs. It's really difficult when your enterprise is trying to figure out what it's doing with its commodity to make the investment in a network that's going to be essential, but only kind of used every now and then. And when that trades off against things like better Wi-Fi on campus for everyone, research networks are never going to make it to the table. And I think what that requires us to do is really sort of rethink this hardware-only science network approach that we've had for a while, because that concept is really kind of 2010-ish, right? The reason that the architecture existed in the first place was back in 2010 when DOE was trying to move massive amounts of data around. The only way you could do it was with specialized hardware. But software-defined architectures have allowed us to change a lot of that. And I think firewalls have gotten better at allowing us to get through them when we're comfortable allowing that to happen. Essentially, it's a different way to get around the safety tags. CC Star, the work that Kevin has done, both with Great Plains, with Oklahoma's friction-free network, and Kent State, all of these experiments are starting to probe but wait a second, you don't just have to go buy a $250,000 piece of hardware to put it on a campus that doesn't have staff to administer a thing so science can be done on that campus. There's got to be a different way with the fabrics of the regional optical networks to extend concepts that are similar. Love the idea of an educational DMZ, because I think this is the mixture that you get in smaller institutions, but you have to be able to get software-based solutions to where the science is, or the science is going to be disabled. And let me finish by talking about the NRP as an infrastructure for equity, right? I think it's really important to understand that the NRP isn't about equal access, because equal access is the bad paradigm. Not everyone needs the same thing. Needs, capacity, equity is what we should be focused on. And if you think about the value proposition of the NRP, right? Think about the buy-in at the table that SDSU, on behalf of the largest university system in the United States, was able to do. So for a contribution of 75 GPUs, we get access to nearly 1,300 GPUs right now, growing. The power law that disintermediates is really critical for us, and it makes everything more equitable, because it means that you don't have to have the same resources that everyone else does to enable your science. So I want to have Chris come up and talk with us about things that are scenic focus in driving this vision forward. But I think it's really important, as we think about all of the great science that NRP has enabled, to not forget that when we think about the democratization of access, it's all about equity, and we have the single largest infrastructure working in the United States right now that's focused and achieving more equitable access to resources for instruction and machine learning and critically science. Thank you. Chris?